এই তো ঢুকে গেছেন। Good afternoon. Good afternoon, sir.
Good afternoon.
Good afternoon.
So, have you started?
Yeah. Now we are waiting for you.
Okay, please.
So you can start now.
So, have you announced the starting of the webinar?
Yeah, just
No, sir.
Oniban is ready to say this thing, but he is
please.
waiting that you join.
Oniban, you please start the webinar.
Thank you, Engineer Sandeep Kumar Dev, Chairman, West Bengal State Center, the Institution of Engineers India, and the newly elected Vice President, the Institution of Engineers India. On behalf of the West Bengal State Center, IEI, I welcome all the honorable panelists and the members of audience. It's an upcoming topic, and we are privileged to have a speaker of the stature of I request Kumar Dev to come address of this webinar.
Good afternoon. Professor Dr. Shimon Chakravarti, Institute Chair Professor, and Sir J.C. Bose National Fellow Dean, Sponsored Research and Industrial Consultancy Professor, Department of Mechanical Engineering, and former Head School of Medical Science and Technology, IIT Kharagpur. My colleague in the committee, Honorary Secretary, Professor Nitish Kumar Brahmo, who is also a panel speaker today. My colleague, Mr. Anirban Dotto, the coordinator of this program today. All my colleagues in the committee who have joined this program. Our president, Dr. H.O. Thackeray, is actually a little bit, his health is not going well. So although his name is there and he's eager enough to join this program, but because of his bad condition of health, very well that this is a very common disease nowadays and he is suffering from that. And so he is unable to join the program. Students, corporate members, ladies and gentlemen. On behalf of West Bengal State Center, the Institution of Engineers India, I welcome you all to this webinar of very interesting topic of microfluid for molecular diagnostics towards technology development on affordable healthcare. Well, let me tell you frankly that the entire topic, I know nothing about this topic, and so it's better not to talk about this because we have very eminent speakers to talk about the topic on this topic. Let me tell you something about our Institution of Engineers, as because I'm the chairman of the West Bengal State Center. So it is my duty to let you know about our own institutions, how it goes on and what are the structures. Our Institution of Engineers India established long back, a century back in 1921. It was registered in Chennai and then the head office was moved towards Kolkata. And since then we are there in Kolkata with 121 number of chapters, which includes state centers, local centers, overseas chapters. And right now we have 9 forums. The recently established fora is the Disaster Management Fora, which is located at Dehradun. As a responsible part of the society, we, the members of Institution of Engineers India, always try to make our contribution to not only to the technological development, but for the social development also. where there is a disaster, where there is a question of skill development, we are there through our state centers, local centers, and the other limbs. My dear friends, you must be knowing that we have a Engineering Staff College of India established almost half a century back, which is there in the Hyderabad, and which we conduct skill development programs, postgraduate programs in engineering and technology, as well as engineering management. So most of the government departments from central government and state governments, they used to send their engineers for training, upliftment of their technological knowledge in SK Hyderabad. I would like to tell you that we have our new president, Dr. H.O. Thackeray, who is basically a civil engineer. He's from Nagpur, Maharashtra. He's now take charge as the president of Institution of Engineers India from the year 2022. And along with them, we are there, two vice presidents, Mr. Sandip Kumar Dev, that is myself, and engineer B.B. Singh from Lucknow are there, our president, along with all the council members. Chemical Engineering Division is 15 major divisions of Institution of Engineers who are constant work in dissipating the technological knowledge, not only among the members, but also the common people. I must congratulate our Honorary Secretary, Professor Nikos Kumar Brahmo, who is in constant, because of his constant endeavor, we are having our webinars in chemical engineering and all other related topics. And I'm glad to say that the quality of webinars, because for the last 2 years, it's not possible for us to gather physically. So we have, because we all are technologists and engineers, so we have shifted to webinar most of the cases, and Professor Brahmo has a lead role in percolating the knowledge of engineering technology through webinar. With this, I would like to end here with a hope that this webinar will also be a grand success by active participation of and the leadership in panelists as Professor Dr. Shimon Chakravarti. With these few words, I once again welcome you all to this very interesting webinar organized by the Chemical Engineering Division. Thank you very much.
Thank you. Thank you. Hello.
Yeah, thank you, Chairman Engineer Kumar Dev. So for your very lucid deliberation on our today's theme. Now, on behalf of the West Bengal State Center, I once again congratulate you for being elected as Vice President of the IEI. Now let me introduce Professor our panelist number 1, Professor Dr. Shimon Chakravarti, who will be delivering today's lecture on microfluidics and recent trends. Professor Chakravarti, he is a professor in the Mechanical Engineering Department of IIT Kharagpur, and also Sir J.C. Bose National Fellow. He has been bestowed as Secretary Government of India, and he is currently the Dean of Sponsored Research and Industrial Consultancy, and majority of his research work is linked up with medical technology, and he has also awarded Shanti Sarup Bhatnagar Award in the year 2013, American mechanical engineer Royal Society of Chemistry, and many other professional and academic bodies. He is also the recipient of G.D. Birla Award for the scientific research. And he has authored and published numerous technical publications in journals of national and international repute. With this, I now request Professor Dr. Shimon Chakravarti to kindly deliver his presentation. Professor Chakravarti, over to you.
Thank you very much, Mr. Dotto, and all other dignitaries who are present here. I would like to express my gratitude to Professor Brahmo for inviting me to this program. We have been neighbors at IIT campus for a long period of time, next door neighbors in our accommodation, and of course we have a different level of personal relationship beyond what each of us do in profession. Having said that, let me enter into this particular topic. And microfluidics or nanofluidics, these are effectively related to the movement of fluids in very small flow passages, and the applications are enormous, as we all understand, mostly in the domain of healthcare technology, keeping in view two important things. Number one, in human body vascular system, we have microcapillaries, which we may imagine as nature-made microchannels, a very complex network of capillary channels. And these channels are very important because the movement of cells, the dynamics of cells, and even the cancer cell progression in the advanced stage, it all depends on the transport phenomena in these microchannels. In terms of engineering applications, in the modern era, there is a lot of development in lab on a chip technology. That means instead of using a traditional resourced laboratory for biochemical or pathological type of analysis, one may take one drop of body fluid sample and do an in vitro analysis in a small device where it is possible to make use of several interesting forces, for example, capillary force or surface tension force, in many cases electrical and other forces, to manipulate fluid motion, and in the process do the medical diagnostics on a small portable unit at the site of the patient, instead of having an elaborate laboratory and a centralized approach of doing the diagnostics. And this, in the pandemic era, is getting more and more relevant, even in the post-pandemic era, where people will realize a lot of challenge in terms of making use of crowded centralized facilities. And instead of that, if there are more personalized facilities where people can make use of these engineering advancements, that will take the journey of having highly accurate yet affordable diagnostic technologies one further step forward. Out of all the different types of diagnostic technologies, molecular diagnostics is one of the most challenging areas. The reason is that molecular diagnostics, it requires a very delicate handling of the samples in very controlled conditions. If there is a deviation from the controlled condition, there can be a spurious contamination which can spoil the entire outcome of the test. So although technologically it may be feasible, but in terms of the outcome of the test results, the reliability may be questioned. And that is why there is currently a lot of research effort in directing the research in miniaturization and microfluidics for diagnostic applications, which are essentially molecular diagnostics, but may be applied at resource limited settings, not in highly controlled lab environment. And while the requirement has primarily emerged from the COVID situation and overall the infectious disease scenario, but the technology being a platform technology could be generically applied for a wide variety of communicable as well as even non-communicable diseases. So with this brief background, I will try to focus more on the molecular diagnostics technology and how microfluidics can play a major role there to make a decisive game change as compared to what is there in the current practice. So I will upload my presentation and then we will move forward. I have purposefully given a very specific focus to this talk because of the limited time. I have already talked very briefly what microfluidics deals about, but I do not want to get into much of theory here because of the diverse interdisciplinary audience, and it would be perhaps more interesting to understand that how those fundamental theoretical concepts may be translated, for example, as a community care. I have very carefully used the term democratizing the diagnostic technology, and I will tell you why such action is very, very important. Again, because this is primarily an engineering audience, so I will give a brief accounting of the biological interface that comes with these diagnostic technologies. If we are interested about, say, testing the existence of a virus, say in a saliva or a nasal swab sample, there could be two possibilities. One is, if you look into the structure of the virus, you will see that in the periphery of the virus as well as interior locations, there are different types of proteins like spike protein, envelope protein, nucleocapsid protein, etc. So in very abbreviated language, these are called as S protein, N protein, E protein, like that. Now, if we are targeting these proteins, then we call it an antigen test. That is the and its point of care form is the rapid antigen test kit that nowadays has become even a household commodity. We can buy it from the pharmacy shop and get ourselves self-tested. So this is one possibility. The other possibility, which is more fundamental, is a nucleic acid test. That means within the virus core, you have the nucleic acid, and COVID-19 as a virus will have its signature in its RNA, the ribonucleic acid. And therefore, testing of the RNA to find out the sequence which is specific to the COVID-19 genome will tell us whether the COVID-19 infection is there or not. So the nucleic acid test is again a very, very important test and considered to be reasonably or significantly more accurate than the antigen test, and I will tell you why. But I will also tell you some of the limitations and challenges. The most common nucleic acid test that we all know is the Rtpcr test or the real-time PCR test. So these are the tests that we do for testing the virus, but if there is an immune response because of either vaccination or previous infection, that can be tested by blood testing or antibody testing, which is called as serology based testing. And typical antibodies, whether they are expressed or not, it can be tested via that. But we all have to recognize that it is more as a surveillance rather than testing, because the antibody will not develop instantly. So early stage of infection, to capture the infection, the antibody test will not be relevant. But whether people in the community had infection or they have developed antibodies due to vaccination, for all these surveillance management, antibody test will of course be very, very important. But today we will primarily be talking about the primary detection test, that is either the antigen test or the nucleic acid test. Now, when we are going to do a particular test, the challenge that has become very, very strong and compelling now is that after the COVID pandemic has hit the global scenario and subsequently Indian scenario, we have roughly 2 years have passed and almost everybody, thanks to media, have become COVID expert. So even if we do not have a clear idea about the different tests, by the media hype and so many programs and so many apparent specialists of the subject, we have developed certain confusions. For example, if a diagnostic test is introduced, is it a screening test or a confirmatory test? Very often people talk about the kit, diagnostic kit. What is that kit? Is the cost of the kit is equivalent to the cost of the test? Is a cheaper test a better test? Is a more rapid test a better test? Are there chances of reagent contamination, typically when we are going for molecular diagnostics? Are the reagents stable so that you can use them in a standard supply chain? Are there chances of cross reaction which can give false positive? Or are there chances that the sensitivity is low so that it can even give false negative? Is the test resource intensive? That means you cannot do it outside highly resourced labs. Is it user friendly so that a minimally trained operator can do the test? How accurate is it? In terms of two important benchmark parameters, sensitivity and specificity. Sensitivity talks about ability to detect a true positive, and specificity is ability to detect a true negative. And is the test method just appropriate, or there is some unnecessary fancy electronics or indirect sensing that compromises with the gold standard principle of the detection? So all these questions are very compelling questions, and when there is a media hype on anything, all these questions get buried under the ground. We will look into all these, and when we try to look into all these, we will try to understand the challenges. The Rtpcr test, we all know, is a gold standard test. There are also issues about the accuracy of the Rtpcr test result, but it is not really related to the inaccuracy of the technology. In many of the cases, it is because of some problem in sample collection and sample management, more than the inaccuracy of the technology. But the challenge is that this requires a very, very elaborate and resourced centralized infrastructure. A real-time PCR machine costs in Indian rupees about say 20 lakhs, I mean plus or minus it will be there. A quantitative PCR, the qPCR, so to say. The ordinary PCR will cost maybe around a couple of lakhs. The real-time PCR machine, even if is available via government subsidy, the challenge is that its operation and maintenance. It is something like this: by some way, by exhausting your resources, you have managed to acquire an elephant. But to give the elephant its food to survive is a hell of a job. So, that maintaining the elephant is like maintaining the RT-PCR facility. The other end of the spectrum is the rapid antigen test, very easily deployable, maybe implemented by individuals, I mean in a self-test mode, or by frontline health workers who may not have any training on molecular biology, but challenge is compromised accuracy. So if we, for example, in the rapid antigen test get a negative result, there is a high chance, and in many cases 50% chance, that it may also be positive, and doctors will recommend a confirmatory RT-PCR test if there are other symptoms which are there along with some indication. So in that way, that compromised accuracy is there, and there is a science behind this compromised accuracy which is not there for the RT-PCR test. If at early stage of the infection, we all understand that early stage of the infection means the viral load will be low. So if the low viral load is there, the concentration of the antigen or the protein is very small in the sample, and that may not be detected by the technology. The same can be true for nucleic acid testing, but one great advantage of nucleic acid testing is that somehow if you are doing a DNA based testing, then you can amplify the DNA. That means if you have one DNA, very quickly by the polymerase chain reaction or PCR, you can amplify to millions of copies of the DNA, just as if you have one piece of paper and you have put it in a very efficient photocopying machine. It will generate large number of copies, and that means that that is what actually the real-time PCR machine does. But as I told you that there are lots of challenges with this. So the answer that we would like to arrive at in this particular talk is, can we combine these two? That means we, instead of antigen based test, still do a nucleic acid test so that we can amplify and therefore detect a very low concentration or early viral infection. At the same time, we do not need a machine of the real-time PCR machine type of sophistication, and it can be used in a point of care format. So what we did accordingly is introduced a testing technology which we named as Piecewise isothermal nucleic acid test. So what it does in the polymerase chain reaction or a PCR test, there is a thermal cycling. You have alternate heating and cooling and heating and cooling, and in that way the DNA gets amplified. So here, instead of that, we are using a loop mediated amplification reaction, so that at constant temperature, by forming loops starting from primers, one can make large number of copies of a DNA without the thermal cycling. So summarily, to implement the test, and I am not getting into the detailed technology because it is there in this published paper and you can see what it is, but to summarize, you collect the swab. It is then it is subjected to, first of all, you have to have the RNA extracted. So you can have a RNA extraction as a formal procedure, or I will show you a further advancement where instead of a separate RNA extraction procedure, you can do a simple heating to isolate the RNA. And then we add certain primers, probes, and enzymes. So the enzyme, one of the important enzyme is reverse transcriptase. What it does is it converts the RNA to DNA. Why we want to convert the RNA to DNA is because RNA cannot directly be amplified and it is very unstable. So we have to convert it to DNA. We know that the central dogma in biology is DNA to RNA and that to protein. Now here we are reversing it. So RNA to DNA and then running this isothermal reaction for about 30 minutes at a fixed temperature of about 65 degrees centigrade. So you have the amplified DNA and the target probes which are there, they will capture the corresponding complementary probes in the DNA strands, just like a DNA hybridization. And in that way, there will be a detection. And how do you recognize the detection? One could be that after the reaction is successful, you may put certain artificial colored dyes which will change color by the reaction. So you can see a visible color, or you dispense the amplified product onto a paper microfluidic strip, which you can see towards the right of this view graph. And this is a lateral flow strip. So this runs by capillary action, a microfluidic action, and you are putting a specific probe. So if the DNA, which is your target DNA, is there, it will be binding with that specific probe, and a surface plasmon resonance, because of the presence of the nanoparticle, will give this test line. And if that is not there, but still you have a capillary flow, a control line will come. So when both the test line and control line come, that means the specific target is there. That means it's a positive reaction that is there. So as the next level of adaptation, what we did is that we tried to eliminate the RNA extraction process as a separate process and integrate it as a part of this entire process in a box. This box is a replacement of the real-time PCR machine. So within this box, we are preheating the sample, that is the nasal swab sample, at 95 degrees centigrade for about 3 minutes. And then we take out that sample and then mix the master mixes, which are for the target genes for our COVID testing. So we have one control gene just to tell whether the reaction is working fine, and 3 test genes, for example, N gene, E gene, and Rtpcr gene. So these are just targets which will tell us whether that COVID specific sequence is there in the nucleic acid. So when then you put up this sample into these reaction master mixes and put in the slot of the machine and run the machine for about 30 minutes. After the products are formed, if there is a color change either on the paper strip or on the reaction tube itself, you take a smartphone image of that and do an image analysis, which has been developed by again our students. And by that image analysis, we can say that which genes are positive and which genes are negative in the test. And we have an algorithm which will tell the overall test summary, that using these, if the majority of the gene is saying positive, we say that it's a COVID positive. And accordingly, within 45 minutes of the sample collection, the test result will come out in the mobile app. And you don't require any manual interpretation. Only the operator's job is to run the machine. So we tested these for highly sensitive detection, where we could test even up to 10 copy numbers. You can see 10 copy of the virus per milliliter is still giving a very faint test line, and it could be detected. And it's a very, very low viral load, and CT value 35 around or plus, and that means it is something which is not that infectious potential. We could also test highly specific detection, and this is very interesting we tested for both COVID-19 and influenza A. And we found that in the same sample, when the patient has COVID but not influenza, we have the test line coming positive for COVID and negative for influenza. Other thing also we have checked, and the importance of this is that in this flu season, there are very common overlapping symptoms like running nose, sore throat, headache, slight fever. So many of these things are very much overlapping between influenza and COVID. And because the protocol is somewhat different for the treatment, if the doctor is able to do an early differential diagnostics as a screening, then the doctor will be able to direct the outcome of this clinical assessment in a particular way, depending on whether flu or COVID is there. For the COVID app version 1, which we developed, we did a testing or validation with ICMR at the ICMR NICED Beleghata, located at Kolkata. And you can see a picture here where their director herself is supervising this validation. And it showed very good results, early results, and it was certified by this body, Apex body. And then we realized that, well, fine, we tested it in a lab environment, although we did not use any resource lab infrastructure, but still within the lab, we wanted to come out of the four walls of the lab. In the process, we recognized the challenge. Outside the lab, you do not have a good reagent storage or supply system in terms of refrigeration, air conditioning. You do not have a high quality, stable power available everywhere, typically in rural places. You have uncontrolled heat, dust, humidity, or even cold, depending on the season. You do not have skilled technicians who are skilled in molecular diagnostics. And cost-wise also, if the test is expensive, when government withdraws subsidy, nobody will be able to undertake these tests. So we tried to adapt this test from point of care diagnostics to extreme point of care diagnostics with this one step sample to result integration in an RNA extraction free format. In this box, COVID app box, we try to first develop some in vitro testing with comparison between test directly from saliva or swab and test with extracted RNA. And we found that very easily up to 1000 copies, both are equivalent, and 1000 copy is about CT value around 25. And we can say that safely for the CT value ranges for which doctor may imagine it to be quite infectious potential and the patient needs to be isolated, there this is able to capture very nicely as a public health recommendation. So I will just run a very small video, and for the interest of time I will not go through the details, but it will give you an idea of how this test runs. So you can see the sample is being collected, and then after the sample collection, the sample is being put up in the this reaction system. You can see here, and then it is heated for about say 30 minutes. And once it is heated and the heating step is over, I will just run through quickly. And then the products which have come out, there is a smartphone based imaging. So the smartphone takes a picture of what is the outcome. So you can see the smartphone is being used to take a picture of the products, and you can see, if it is zoomed, you will be able to see that you will see a yellowish color. So from pink, the initial reagents, to the yellow, this is a positive indication, and this tells very quickly whether it's a positive test or not. So in IIT Kharagpur, we have been doing this test for the last, I would imagine, 4 or 5 months on campus people, along with campus visitors. Typically in the convocation, we had quite a good number of visitors. This is a validation report when we had about 800 samples tested. Now we have more than 2000 samples already tested, and you can see the quite high sensitivity and specificity. For example, I mean, standard rapid antigen, even the best ones will not have more than 70% on an average sensitivity. And here we have about 95%, which is the nucleic acid benchmark for ICMR to approve the nucleic acid test. Now, what we realized, see, the situation is continuously evolving. So all of you have heard that from yesterday, the state government gave a notification that all schools will now open, except the primary schools. In other states also, it is happening in that way. So up to class 7, it will be like a small tutorial mode, the so-called Pathshala mode, where a few number of students, they will be supervised by teachers in a common gathering place. And from class 8 onwards, the students will undertake the regular class. And we have to imagine that this is actually a very vulnerable part of the community. These are not vaccinated people. Most of us who are senior people who are vaccinated. This is a vulnerable young group, not vaccinated. They may have a natural immunity because they are young and agile, but they are not vaccinated. So they will be at some danger. The challenge or the unbalanced nature of us as civilian citizens is that we are extreme-minded people. When imagine 25th December, when there was a whole lot of festive mood going around, people were flocking around in parks, in Digha, and so many other places. Just after 2 days, as if magically COVID arrived, and everything was almost planned to be closed for some time. Everybody became panicked. The news media, which were very much interested in showing other items, suddenly started showing scaring news about the Omicron and the other things. So we are very unbalanced citizens. For a long period of time, people were complaining or crying that because children are not able to go to school. I am reminded of one very interesting story that I have I read in my early days, young days, written by the famous author Narayan Gangopadhyay in Bengali. So his his elder brother was going to school, and he was not going to school because of young age. And when the Guru Mashai, that priest, came, then he complained that my elder brother is going to school and I also want to go. He started crying. And the Guru Mashai told a very interesting thing. He said, today you are crying for going to school, at some day you will cry for not going to school. So the thing is that we are very unbalanced. So today everybody is, it's as if a success of campaign that all schools are opening, but God forbid, if something happens in many schools, people will again shout that, well, government is very irresponsible. So why put blame on government? Let us be careful ourselves. So we need a testing technology by which these children, the most vulnerable part of the society, when they are not vaccinated, they may be tested. And testing them every day with a nasal swab collection is very, very challenging. Those of us, I believe all of us who are sitting here have got COVID tested at some point of time or the other. Imagine when your nose is poked, it is not very comfortable. I would imagine that blood testing is more comfortable than that, at least from my side. So instead of that, we have developed a technology which is currently under development, but I will show you an interesting thing. So instead of poking your nose, you simply have a saline gargle sample. So this is a demonstration of how the saline gargle is being collected. So a gargle solution is being given to the patient. So you see a bag is being opened, and here there is it's simply a saline solution, salt water. So you put it in your mouth and do a very vigorous mixing inside your mouth in a particular way. I'm sorry. So I'll just I'll pass it on. So you see how it is going on. And in the process, after it is being collected, so I was trying to run it fast, and that is why it stopped. So let us run it. So in that way, after this is done, you will see that it is being put back into a larger sample collection tube, which is very much similar to the sample collection tube for the swab sample. And then this can be put into this nucleic acid test or the antigen test exactly in the same way as we do for the other tests. So the early results are very, very much promising, and we are doing more and more clinical trials, and we will try, be very happy to give it to the hands of different pediatricians or schools, just to try it out and see how it is happening. It is not affecting anybody. It is not, it is completely non-invasive or even not minimally invasive. So I think it is going to have a positive impact when we have to keep the schools and other organizations open, but we have to be very, very careful. So this balanced approach will be required. I will give you a couple of case reports very summarily. I do not want to get into these full results, but the whole idea is that these patients approached our BC Roy Technology Hospital at some point of time when the Rtpcr test, this is about the second wave, when the second wave was having a havoc. The Rtpcr test from our Midnapur hospital was getting delayed by 2-3 days. It was so much of rush. Also in weekends, we normally do not get results, but the patient had to be treated. And the patients were treated using just the Covirap test result, which was available. And later on, it was found that it was correct, and the doctor started life-saving interventions, and in that way, it saved several lives. Now, the question is that finally, COVID is important now. We all expect that within the next few months, because as the viral infection evolves, from the pandemic, it is coming towards endemic. So it will, very hopefully, very soon be something like a flu, and but it will be a part and parcel of our daily lives, just like flu. But it will not be that negatively impactful as it has been over the past 2 years. But that doesn't mean that the infectious disease world is over. It also doesn't mean that in COVID era, no other infectious disease is there. There are so many other diseases, including the vector-borne diseases, which have been there, which will remain, and which will evolve with time. And what we have developed is not just a COVID-specific test, but a platform technology for piecewise isothermal nucleic acid testing, which can be used for diagnostics of this kind. So we have we have understood all this, and in the process, what we have done is we have developed a manufacturing paradigm which makes sure that this technology is commercialized. We have transferred the technology to companies and developed a manufacturing paradigm. You can see in 2020, we got the first in vitro validation. In 2021, it was having a gradual transfer from the lab to the engineering prototype. And in the 2022, it is all projected to be launched commercially. So the whole impact that we envisage out of here is its outreach in the rural healthcare centers, the digital health clinics, the public places, restaurants, malls, train stations, airports, marketplaces, and schools, where we want to establish normalcy, but we don't want to sacrifice public health management. Pharmacy and medicine shops, individual use, and possibly a substitute of the rapid antigen test, which is quite easy to do, but not so accurate. And we have already converged this with other initiatives of rural healthcare, in which my other innovated medical devices or diagnostic devices have been interfaced. And all in all, we expect that it will give a whole lot of livelihood generation through entrepreneurship, enterprise formation, and the empowerment of frontline health workers by virtue of their training to do this testing. So to summarize, it's a one-step sample to result solution, a low cost, about 8,000 rupees per instrument, where you can do many tests as opposed to an expensive PCR machine. Not just one-time cost, but also maintenance is, it's just like a consumer device which you can put up in power, just like our induction cooker, and put it up anywhere. It is a unique amalgamation of advanced nucleic acid based molecular diagnostics, but disseminated in the format of an affordable rapid test. And hopefully this will be having a holistic impact, cutting across the society, and democratize the availability of resources and eradicate the difference between the rich and the poor, or haves and the have-nots, in terms of getting access to molecular diagnostics. I would like to acknowledge various teammates, starting from the faculty members, colleagues, and students, other staff, without whom this research could not have been materialized. Thank you very much for your patient listening to this talk. Professor Bromo, I think you are muted. So, Professor Bromo, you are muted. I mean, I cannot hear what you are saying.
Professor Bromo, kindly unmute yourself.
Muted, actually.
Professor,
Can you hear me, Anima?
yeah, Professor,
Can you hear me?
Yeah.
Yeah. Thank you very much.
yeah, we can hear you. We can hear you. Yeah, let me first thank our first panelist.
It was
We
excellent.
sincerely express our thanks and gratitude to Professor Dr. Shimon Chakravarti, because we understand that his deliberation would act as a myth buster towards the COVID testing and its associated myths and many falsified notions associated with COVID and its testing. And without going deeper into the technical part, because I am not having that capability to get into it, because being a mechanical engineer, to me, fluid and its conveying is restricted to plant only. But one very important social message Professor Dr. Chakravarti has given, that is the responsibility of the citizens. That definitely would act as a very important thing and very important point to ponder. Thank you, Professor Chakravarti. Now I request, I introduce our next panelist, Professor Mitosh Kumar Brahma, who is a very eminent professional and eminent academician and he has actually worked in different fields in the domain of chemical and biochemical engineering. And he has written from the Max Planck Institute, and at present, and he has served as scientific officer in Indian Institute of Technology, IIT Kharagpur. And at present, he is associated as a guest faculty member in Institute of Genetic Engineering, Madhumgram. And last but not the least, he has been served the responsibility of Honorary Secretary of West Bengal State Center for the outgoing state committee. With this, I request Professor Brahmo to kindly deliver his lecture. Over to you, Professor Brahmo.
Thank you, Animans. I'm very much pleased to hear your announcement regarding me. Anyhow, I spent a lot of times in Germany regarding all kind of research related to physical chemical engineering as well as the biological chemical engineering. One of the most important issue that I kept in mind when I was in Max Planck Institute to observe how bacteria, I was very much associated with microbial engineering as well as the microbes, and especially with bacteria, because a lot of bacteria are pathogen, non-pathogens, everything I have observed, and their attitudes during pathogen system and non-pathogen system to human. One of the most important issues that I observed when DNA double helix was discovered, it was very much spontaneous to the world to see how the vitro system can be manipulated to a vivo system. You understand the vivo and vitro mean vitro, what I see in the lab, and vivo means what I cannot see in the lab, but I can optimize the both in the systems of a particular molecular movement. And that molecular movement is the DNA, RNA, and the protein. Now, this is the dogma has been clarified by Professor Shimon. Is brilliant. In my word, there is no word till today that I have seen in IIT as well as in my surroundings, except in Germany. But the Germans were very, very isolated in that system, not to share. But with that introduction, I have to say I have not very much time. I will complete. I can request my colleague, or also called my assistant, to highlight the slides. Yes, from the beginning. Go to the top. Yes, that's the first. No, this is the first slide. Go to the top. Oh. এই তো এখানে ক্লিক করো না bus. Yes, so my topic is a bio-nanotube, its application in vaccination and cancer therapy. Well, you can say that it is a just imagination. It cannot be fruitful in the practical life, but I believe differently. The most of the important aspect that I observed, it was the adherence. If you stop the adherence, then no bacteria, no cancer, no viral cell can do their jobs to the respective areas. Let us say the cancer, they need also to adhere and then to grow and be stopped by certain medication to benign and malignant. That is one way. Now the question is why you say bio-nanotube? Is a fact that everybody will ask, and complicated, but it's not. Now, if you see the next slide, I can say that what is my objective? The vaccination, cancer, bio-nanotube, microfluidics, hybrid genetically engineered coli, and bidirectional immune response. I have not completed these all the facts in that respect to apply and to make it in social and to say, yes, this is the process is applicable to the human system. My observation is to understand this. Really, you can say what will be the fact if you understand this. It is very important to understand the adherence. The experience that I've observed in the Max Planck is with the research. Means basically, I am very much interested in the research and to understand the new things, which is not very easy. It's a hard work, and it may provide you several bad explanation or a damage to your system of education, because it is a very, very critical in our society, especially in India, to catch a new thing and to carry and support by the colleagues or by the institute to continue. But in Germany and in America, they are very much adamant in that respect. They can continue, etc. So vaccination, what is vaccination? Vaccination is that a process where your bad elements can be captured and could be dissolved in that respect if the enzyme lysozymes has been created. In our system is bacteriophage in that respect, so bacteria, and our system is a macrophage. Macrophage means the white blood cell actually going around, and whenever they are getting enemy cells, they recognize with the antibody. That means antibody is to be developed along with macrophage, the white blood cells, also called granulocyte, and so all big cells. The cancer is the very clever systems in the body, and that can be developed according to your immune system. Means either you are vaccinated against the cancer, or you have a self immune system generated in your body by exercise, by good health, by good process. Most of the cancer is being generated due to negligence of the health system, and that has been proved. Smoking, drinking, and all these things which are adverse to your body. Bio-nanotube microfluidics that are mostly developed partially. It has been carried out from Max Planck concept, and as well as some properties of the bacteria, as well as some to see how adherence are being made. That means if it is something secretion not comes from the cell, it cannot adhere. And if they don't adhere, they cannot colonize. And if they don't colonize, they cannot also create any infection. That is the fundamental. Now the microfluidics comes in that concept that there should be some microchannels or nanochannels between the cell wall. In case of bacteria, is a prominent cell wall, and in case of viral, as far as the means the corona, so they have a very labile cell wall. Means they have some spike proteins or some proteins which is very labile, means not stable, and they create they secrete some enzyme which will attack some kinds of lung cell alveoli, where they will attach and discharge the RNA to the cell to multiply. Okay, so they must have to attach. They must have to adhere. So my objective at that material term and also in IIT, how I can develop some enzyme, some protein, which can protect this kinds of adherence. But I should be very specific to particular infective bacteria or so-called elements which will be entering in your body and will try to adhere particular organs. That means here it cannot be generalized. It should be specific to organ as well as specific to microbes, viral, and any other secretions of the plant and animals. So these are the specific. We have not developed, or I have not developed any concept that could be generalized. Hybrid genetically engineered coli. Yes, that is a very interesting word, genetically engineered. What is genetically engineered? Genetically engineered is that you have to develop in vitro some process, some protein, some RNA, some DNA, which could be allowed or to be entered into E. coli K12, and that should be accepted by the Escherichia coli, which has been generated in Yale University as Yale strain, and with a very standard bacteria, non-pathogenic bacteria. They were pathogen, but slowly they have been mutated and considered in the lifespan, also called in the life history of the Escherichia coli as C600 E. coli K12 Yale strain, and C600 is the number which is considered as universal recipient. Means that manipulation inside is so enlarged or so developed that each and every DNA sequence to be known for the scientists, and the vitro made some DNA, some they should accept that genetical areas where they can be introduced and could be expressed. It is a vast process. I'm not going there. Bidirectional immune response is that the system that I've developed in IIT, also called I have theoretically developed on the basis of my calculation, on the basis of my imagination, that this bidirectional immune system can be very appropriate to a cancer development, that the bionanotube will be immobilized by the cancer drug, and that will be transmitted to particular infected area where they will be secreting at the same time, because it is a bionanotube, because it has been made with the Escherichia coli, and that means they have no side effect as a CNT carbon nanotube. They will recognize the body system. At the same time, they will be releasing the cancer drug, and the cancer drug will be attacking along with that bacteria, along with the bacterial system that has been generated with the DNA isolated from cancer. And that is the logic, I believe very strongly could be introduced in future. So next. I'll be talking cancer. I have already been completed. I will not be repeating that. Cancer conceptual and development, I already said. Immune system that controls the benign and malignant, partially said how a cancer patient is killed. Actually, people say he has been died in cancer. It's not. The cancer patient is actually spoiled his immune responses in such a vigorous manner by during chemotherapy, radiotherapy, during all kinds of artificial scans. The drugs, they cannot be immunologically strong enough That means we are actually been grown with all bacteria in our body, and that system actually they are getting slowly according to the age in the form of opportunistic infection. Means they will be waiting when my opportunity will come, and immediately they will be exposed, and drugs will be really, we say the drugs mean antibiotics, one of the most dangerous elements that we take. Even in the corona, we are attempting to take antibiotics, and that antibiotics not only kills that viral, not only kills the bacteria, but also kills our good cells. And that is the danger where the multi-organ failures is occurred, and thereby either heart failure or any kinds of body failure, kidney will be exposed, and thereby a patient will be killed. Now, my overview objective, I've already introduced something, introduction. I'll be talking a little bit, materials, methods, I'll be talking something, results and discussions I'll be also covering. Objective. Bionanotic, the word of Escherichia coli, is nothing but a genetically engineered E. coli, and that genetically engineered E. coli is been made with the help of the DNA or RNA, whatever it might be possible, to clone that bacteria and to isolate some kinds of extended pili life fimbriae. Fimbriae, I'll be showing you that picture, which will be very common to you, will be also understandable how this fimbriae is actually supporting the process of adherence, process of colonization. So with that, I'll be moving slowly to the next. The time is warning me not to continue and to show rapidly your objective. Now, this I've just given, you can take over my slides and to read that thing. These are the common things that I've extended here. Fimbriae, next slide. Bionanometry, how you are coming to that questions of bionanometry. Yes, very good concept. I partially developed, but I have to prove it by immunization system in vivo with the animal. Anti-adherent system is being proved, but immunologically, bidirectionally, and the growth of benign tumor to malignant and to keep it in benign is not being completed, or so-called is not being used or so-called researched. Now I skip and say something about the BMT. Now, if you see the bacteria in electron microscope, enlarged near about 4,000 or more than 40,000 to 4,000 and extended to 1 lakh, 1 million, then you would see that this picture I have drawn by observing electron microscope. There are 2 types of bacterial cells. One is round and another is longitudinal. But at the same time, they are fimbriae isolated. These are the isolated fimbriae. They are being associated in 2 different manners. One is a longitudinal and it's a very attaching form. Other is so-called is a scattered form. Now with that, I have to go some slides, which was observed many years ago. One is a flocculation, how bacteria actually flocculate in wastewater treatment, and then in the normal microscope near about 5 to 1,000 enlargement, and how they can be associated in that picture. And thirdly, Yes, this is a very important issue that I've kept it in agarose gel electrophoresis. Here is some kinds of PCR, some kinds of system which was made in the multiplications of the DNA, etc. Professor Shimon has observed a lot of things. This gel, in my time, at that time, near about 10, 20 years ago, was a very simple system. We have to observe all kinds of bacteria with the characteristic by the plasmid. Here is all the isolated plasmid. The DNA molecule is being characterized by the plasmid. Why? What is plasmid? Extra chromosomal gene, and that could be developed during pathogenic mode, as well as they could be abolished non-pathogenic mode. These are the very simple type of educations that could be converted by young students or graduate students or postgraduate students or research students. They can be analyzed on the basis of their pathogens, how this mode of plasmid, the mode of extra chromosomal gene comes out from the chromosome, would be organized. And this is the system that I've drawn on the basis of my conceptual idea, how bacteria adhere with the cell, that there is some fluid flowing system must be there. How you understand that the fluid system must be there, and on the basis of the pathogen, you have the serological so-called H serotype and human blood agglutination system, where that can be explained whether it is a pathogen or non-pathogen. That means whenever it is a pathogen, it will agglutinate the blood cells of the human or any kinds of animal to make it in the granular form. I have a lot of other pictures that I'm not showing here. And now the philosophy that has been matched with the downloaded picture, how bacteria is actually motivated to adhere or to colonize. Now, on the basis of that, the concepts of the fluid flowing from bacteria to cell or the surface of the colons, I have isolated that fimbriae and immobilized with araldite, and that has been observed that the araldite, whenever it is immobilized, they make some kinds of dots, and that is not made pure araldite. It is not giving any dots. So on the basis of that, then I have asked, how could I prove that this is a tube? So suddenly I thought that there is a system in our membrane system technology that very slow, very low pressure, also called the pressure drops. A water, if it flows from that system with fimbriae, then I have to conclude there is some channel. And if it is not flowing, then I have to conclude that there is no channel. That has been proved. And now, now the question is how this can be utilized in the regular vaccination process. That means you can immobilize this type of things with the drugs applicable to a very amicable environment to control tumor or so-called other types of infections of cancer, so-called in the preliminary stage. And this is also being characterized by syringe and the pressure drop. And some part I have studied with the Professor Shimon to observe the negative pressure drop in his instrument during my IIT stay. Now, next slide, I have only 3 slides. I'll be completing within 10 minutes. Conclusion? Yeah. Conclusion, I'm just reading nanotechnology, BNT application in vaccination, in cancer and in corona treatments could have taken important role if it needs many more experiments. Nanotechnology and microfluidics have taken a new and important role in engineering and scientific activities. If the adherence of corona spike protein could have been protected by vaccination using BNT-based anti-adherence immune response protein, it would be a new biological evolution or revolution. Anti-adherent immune response vaccination supposed to be a new genesis in pandemic. You see, the mutational aspects of corona is a very, very dangerous because of RNA. It's a spontaneous mutation, means one ATGC in respect of RNA, AUGC, is a dangerous. It's a dangerous mean I'm also lost to understand how quickly they are mutating. One of the things that I've studied in the bacteria is a jumping gene. That means whenever the RNA or DNA is moving, they can actually hybridize each other and create a new mutant, also called mutational viral system or bacterial system. And that is a very, very dangerous compared to bacteria. Bacteria has a long chain of DNA molecules in the chromosome, but the viral is near about a few hundreds of RNA, so-called nucleotides and the product adenosine, cytosine, uracil, and guanosine, and thymidine. And these are the four items of our system can be mutated very quickly. Conclusions continuing. Now, well, conclusion. Global corona pandemics have changed not only global industries, 4.0 industrial revolution, but also the human relation. Darwin's third law, survival of the fittest, as a biological evolution, have taken new look. Means the fear factors of the corona at the same time masking and isolating and no, you should not come here. All the system mistakes and to practicize is really our freedoms of movement has blocked, and that freedoms of movement has also changed our relation in the normal relation to a particular specific relation. Green chemical business and regenerative medicine in support of bio-nanotube could be more appropriate in sustainable and hybrid environment of agriculture, medicine, and process industry. The innovative applications of BNT is unique and need experiments. Literature that I've given here. I thank Dr. Nilanjan Sengupta, Director Technical IEI, allowing and requested me to present a talk. I thank also the existing office bearers who were continuously helping us to develop the academic environment in this Bengal State Center IEI using webinar at present pandemic. Last but not the least, I do hope that my presented paper will inspire new possibilities to work further on bio-nanotube applied in sustainable development of regenerative medicine, molecular engineering in future to control infectious diseases, pandemic, cancer, climate change, and lost human reaction. So these are my imagination that we should be very fair to work in the research. Sabotage and all these things are going on. And Rabi Thakur said, "Dao Firesha Aranda Lohe Nago," by which is not applicable to our present system. We have to optimize it. With that, I thank you all the panelists, respected panelists, and the coordinator and the other observers. Please, if you have any questions, ask. Thank you very much.
Yeah, thank you, Professor Brahmo, for your excellent presentation,
Okay, thank you.
which covered many angles of
Okay.
microfluidics, which can of affordable healthcare. And there are two questions which have come from our audience. Yeah, first question is by Dr. Syed Ali Hashim.
Sure.
He has asked, "Good evening, sir. How long will it take to reach the market?" I believe this question is directed to Professor Dr. Shimon Chakravarti on the test kit, on the development of test kit. He has elaborated in his presentation. Dr. Chakravarti, would you like to put some light, throw some light on this question? Dr. Chakravarti, can you hear us?
Sir, I think he has left.
I think
Yes, left.
I also see that he has.
He has
So,
left. Yeah.
as a moderator, I express my sincerest thanks to both of the panelists, because we have heard in many seminars, conferences, and webinars from Dr. Brahmo, Professor Brahmo. So, but today we have we had the fortune of having Dr. Chakravarti as well, and his presentation, particularly on development of the test kit, that is really, that will be a benchmark for the affordable healthcare.
Yes.
So now I request Professor Brahmo to kindly put the vote of thanks as to.
Thank you, Animan. I'm just giving the vote of thanks in that form, that because I have already discussed my matter, so I will not be going back. I'm just taking the formalities of the vote of thanks. It is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical web and microfluidics for molecular diagnostics towards technology development in affordable healthcare, organized by Chemical Engineering Division of West Bengal State Center, IEI, through online platform. At the outset, I convey my sincere thanks to all the panelists, Professor Dr. Shimon Chakravarti, Institute Chair Professor Syed Jeshibos Nations Fellow, Dean Sponsored Research and Industrial Consultancy Professor, Department of Mechanical Engineering and ex-head School of Medical Science and Technology, IIT Kharagpur. Professor Nitosh Kumar Brahma, Honorary Secretary, West Bengal State Center, ex-faculty, IIT Kharagpur, and visiting faculty, IG Badu, Kolkata, on today's technical webinar, who have very nicely deliberated their lecture. My sincere thanks also goes to my colleague, Mr. Sandeep Kumar Dev, Chairman, West Bengal State Center, IEI, and our beloved President, IEI, Dr. H.O. Thakre. My heartfelt thanks also goes to Mr. Anirban Datta, convener, Chemical Engineering, Mechanical Engineering Division Subcommittee, West Bengal State Center, IEI, and Mechanical and Piping Research Design Service India Private Limited, a fully owned subsidiary of Richard Industries Group, USA, who act as moderator of today's program. I convey my sincere thanks to all members of the council, division board members of the CHDB, all members of the committee, West Bengal State Center, IEI, all members of Chemical Engineering Division Subcommittee, West Bengal State Center, IEI Director, technical and this team of IEI for the wholehearted support to make the program a grand success. Last but not least, my heartfelt thanks all goes to all who were behind the screen to make today's technical webinar a success. Thank you very much. And happy New Year 2022. Yeah, Animal. Hello.
Thank you, Professor Bromo. With this, we can proceed for closure of today's webinar. And once again, in addition to the formal vote of thanks, I thank you all for your patience hearing.
Yeah, thank you.
I request Mr. Shimon Chakravarti to kindly stop the live streaming.
Okay, sir.